Right, welcome grade 12s. Let's look at some of these from exercise 5. Okay, we want to reduce all of these angles that are not acute positive angles down to their acute reference angles. So if we look at 337 degrees, we can think about that visually as, well, this has gone almost all the way around back into the first quadrant. This would be negative 360. This is negative 270. So in fact, this is in quadrant 1. Right. And we of course know actually if the function is positive, and we know if the function is squared, that it's going to remain positive. What we really care about is what is this reference angle here. So if we take 360 degrees and we just minus that positive angle, we're going to see that that is 22.5 degrees. Now that angle as well, we should realize in grade 12 that this is half of a special angle, and so we realize that that probably is going to come something like 45 degrees. Alright, the cos of 300 degrees, that's in quadrant 4. And that leaves us with a reference angle of 60 degrees. Cos in quadrant 4 is positive, so we keep this as the positive cos of 60 degrees. Now we're adding the tan of negative 45. Well, this is also in quadrant 4, where tan is negative. And so we're adding the negative tan of 45 degrees. Okay, right. Well, we can't do anything with the sine squared 22.5 yet. At the bottom here, the cos of 60, well, this is now a special angle. The cos of 60 is 1 over 2. And the negative tan of 45, well, we can change this into minus 1, adding a negative, and then tan of 45 is 1. And if we look at what we've got here, so if we divide by a half, it's the same as multiplying by 2. You can multiply by 2 on both the top and the bottom. You've got 2 sine squared of 22.5 degrees minus 1. Well, this is really close to our cos double angle. If you recall, 1 minus 2 cos squared a is the cos of 2a. So if we factor out a negative here, we can change this into the negative of 1 minus 2 sine squared 22.5 degrees. And then this part here is your cos double angle, so this is the negative cos of 2 times this angle, the negative cos of 45, which is the negative of 1 over root 2, or the negative root 2 over 2. Okay, let's look again here. We've got a whole bunch of angles that need to be reduced. So let's go systematically throughout these. Again, if we've got a squared ratio here, then we know that the ratio is going to remain positive, because even if this was a negative ratio, when you square it, it's positive. The reference angle here, if you've got 204 degrees and this is 180, then you're looking at a 180 plus 24 degrees. So this is 2 cos squared 24 minus. Okay, well, now let's go and look here. This is 150 degrees, that's in quadrant 2, and that leaves us with 30 degrees here, which means sine, and of course it's sine and positive in quadrant 2. So I've got minus the positive 2 sine of 30 degrees. Now that's a special angle, 30 degrees. Let's go and see what happens down here at the bottom. Okay, 320 degrees is almost a revolution. That's in quadrant 4, where this here will be 40 degrees to get me up to 360 if this is 320. So cos in quadrant 4 stays positive, and we can reduce this to the cos of 40 degrees. Cos of negative 8, well, this is also in quadrant 4, and that's the cos of 8 degrees. Plus the sine of 220, well, that's going to be 180 plus 40 here. That would give us 220, but this is now sine is negative, so we've got the negative sine of 40 degrees times the cos of 82. Well, the cos of 82, this is just a reference angle. The cos of 82 is purely in quadrant 1 here, so we've got the cos of 82 degrees. Okay, so let's go and see what we've got here. If we look at the top here, we've got 2 cos squared 24. Well, 24 is not a special angle, but this 2 times the sine of 30, 2 times cos squared of 24 degrees, minus 2 times the sine of 30 is a half. And we must show that we know that that angle is a half. At the bottom here, we've got the cos of 40, the cos of 8. And then we're going to go and say, well, this is minus the sine of 40. But if we notice, you've got the cos of 8 and the cos of 82. Well, those are complementary angles. And if you notice here, we're looking also at our cos compound angle identity. So if this is the cos of A, cos of B, and we've got a minus here, well, then we want the sine of alpha, which is what we've got, 40 and 40. But then you want here a sine of beta, and these angles need to be the same, and 82 and 80 are complementary, so we can change this angle to the sine of 8 degrees. So here we've got cos of 40 times the cos of 8. Okay, so let's go and look at this compound angle at the bottom. This is your cos. If we're subtracting these ratios, we know we're going to add the angles with cos. So this is the cos of 40 plus 8, which is 48. Now that's quite interesting because at the top here we've got 24, which we notice is half of 48. And if we look at what happens at the top, we've got 2 cos squared 24 degrees minus, and 2 times a half is 1. So at the top here you've got your cos double angle. So this is simply the cos of 48 degrees divided by the cos of 48 degrees, which is 1. Alright, so let's look here. We have got some angles here that need to be reduced. So again, because it's squared, we're not actually interested in the sine of it or the quadrant apart from the reference angle. So 165 is in quadrant 2, which leaves us with an angle of 15 degrees. So we can reduce this to the cos squared of 15 degrees. The cos of 60, well, we can immediately replace that with a half. Okay, the cos of 97 degrees. This is in quadrant 2. Although this is just past 90, we don't want to look at the angle that goes to the y-axis. We want to look at the angle that goes to the x-axis. So if this is 97 degrees on this side, then back to the x-axis here, we have an angle of 83 degrees. So this reduces to the cos squared of 83 degrees. 727 is 2 revolutions, and if we're back here, this is 720, then we're looking at an angle here of 7 degrees. So we have the cos squared of 7 degrees. Again, we see that if we divide by a half, it's the same as multiplying by 2. You multiply by 2 on the top and the bottom, you can think of it that way. So you have 2 cos squared 15 degrees. I hope you can see where this is going. Then over here, well, notice that 83 and 7 are complementary angles. And so we're thinking about, well, then cos and sine would be complementary. Now, do we want to change one of them? Well, let's see what happens here. First of all, if I take the negative out there, then this becomes positive. Now I'm looking at cos squared 83, and I'm thinking, well, this here could become the sine squared of 83, which is my grade 11 Pythagorean identity. So I've got the 2 cos squared 15 degrees minus, and then this thing becomes 1. And then 15 degrees, of course, would be, this is the double angle cos identity. So I can write this as the cos of 30 degrees, double 15 degrees, which then is going to be equal to the root of 3 over 2. Okay, let's have a look at question D. These are not, in the numerator, we do not have reductions, 40 minus x and 40 minus x. The 40 degrees is not on our x-axis or our y-axis, so we can't reduce it in terms of x. What we're going to do is we're going to go and expand each one of these out. So using our compound angle identity at the top here, we've got cos of 40 multiplied by the cos of x, but we're going to add, because we're subtracting the angles with cos, sine of 40 degrees times the sine of x. Then we're going to, but now remember that we're multiplying all of that by the cos of x. Let's look at what happens with the sine compound angle. We're going to have the sine of 40 degrees times the cos of x, and then we have the same sign, cos, but because of sine, we have the same sign with the sine compound angle, so then we're going to go cos 40 degrees times the sine of x, and all of that gets multiplied by the sine of x. Okay, at the bottom we've got some reduction to do here. So 205 degrees is in quadrant 2. So we know that the sine is going to be negative. And then this angle here is going to be 180 degrees plus 25. So we can reduce it to the negative sine of 25. 155 degrees is also in quadrant 2. So we know this ratio is going to be the negative cos of also a 25 degree angle. 180 minus 25 would give me 155. Okay, and the numerator here, we need to go and distribute that cos of x to both terms. And here we're going to distribute the sine of x to both terms. So if we go and look at what happens here, we've got the cos of x times cos 40 cos x, which means that we're going to be looking, we're not going to multiply both, but the cos squared comes from there, plus here we're going to keep the sine of 40, and we've got the sine of x times the cos of x. Alright, here we're going to now, let's bring this in here. Remember, we've got this negative in front. So when we multiply, we're going to have negative sine 40 degrees cos x sine x. And now if we've got this negative in the front of the bracket and a negative here, and we're going to multiply in here, we're going to have the positive cos 40 times sine squared x. Okay, what's happening in the denominator over here? Well, 25 is not half of a special angle, but we do notice this pattern here, which looks very close to the sine compound angle, 2 sine a cos a. But of course we're missing this 2. If we realize that we could multiply half in the front to get this coefficient of negative 1, well, positive 1 when we look at the signs, then we realize at the bottom here we can actually write this as the half the sine of 50 degrees. Now, why am I looking at 50 degrees? Well, I'm also noticing these 40 degrees in the numerator, and the 50 degrees and 40 degrees are complementary, so we might be able to do something with those. Okay, what happens in the numerator here? Well, if we look here, we've got the sine, positive sine 40 cos sine x cos x, and then we've got minus sine 40 cos x sine x. Those are the same term. So if I added and subtracted, we've lost that. With these numerators here, we've got a cos 40 cos squared and a cos 40 sine squared. So the cos of 40 degrees is a common factor, leaving me with cos squared x plus sine squared x. All of that over the half sine 50 degrees. Now here comes in the 40 and the 50, cos and cosine, or cosine and sine. So we can rewrite one of these as the cofunction. So I can write the numerator as the sine of 50 degrees. If we notice in the bracket, we've got our grade 11 Pythagorean identity. Cos squared plus sine squared of an angle is 1. And then we've got a half times the sine of 50. So the sine of 50 divided by the sine of 50 is 1. You could have made the denominator, this one cos 40, would still give you 1. And then we've got 1 divided by a half, which would leave me with an answer of 2. Okay, all right, E with the star, a bit of a challenge here. Let's see what we can do. Okay, the cos of 2 degrees plus the root 3 sine of negative 2. Well, we realize that this here is going to be multiplied by the negative sine of 2 degrees. Now noticing that those angles are the same. Alright, let's see what happens at the bottom. We've got 4 sine of 346 degrees. This here is in quadrant 4, leaving me with an angle of 14 degrees to the x-axis. So this is the negative sine of 14 degrees times cos of 194 is in quadrant 3, 180 plus 14 degrees. So this is going to be the negative cos of 14 degrees. Okay, well, let's look at what happens in our denominator here. This here is very close to my sine double angle, but of course sine double angle is a 2 sine A cos A, so we're going to have 2 times the sine of 28 degrees. Alright, let's go and look at what we can tidy up in the numerator here. So I've got the cos of 2 degrees, and then here we're going to say minus the root 3 of the sine of 2 degrees. Okay, if we are dividing this numerator by 2, we can also think of multiplying that numerator, each term there, by a half. So if we wrote this, right, that might look uncomfortable. So if we look here that we've got this numerator and we are dividing it by 2 times the sine of 21, sine of 28. Well, isn't that the same as taking that numerator and multiplying it by a half? And I can still think about multiplying this by the sine of 28 degrees. But it's helpful for me to think about this numerator, bringing that half up into the top and distributing it to both terms. This leaves me with some special angles here, that a half, I can write a half as either the sine of 30 or as the cos of 60 degrees, and I can write the root 3 over 2 as the complementary angles there. So this would be the cos of 30 or the sine of 60 degrees. And it doesn't actually matter which one you choose to do here. So I'm going to, because I've got sine at the bottom, I'm going to choose to do sine of 30 degrees times the cos of 2 degrees minus, here's my root 3 over 2, this is the cos of 30 degrees times the sine of 2 degrees. Now you'll notice that when we do that, this is my sine compound angle, the subtraction of the angles. And so in the numerator, we're going to be able to write that as the sine of 30 degrees minus 2 degrees, which of course is 28 degrees. And therefore, this is also equal to 1. All right, I hope that helped. Best of luck.